Welcome to Spring Lib.
Hello students, let's solve this question. Here it is given that the wave frequency f is equal to 493 Hz and the speed v is equal to 353 meter per second. We know that the wave equation is given by y of x comma t is equal to a into sine omega t minus kx. Here this value is 5. So this is a phase of the wave. Thus we can write the phase difference will be equal to del phi is equal to omega delta t minus k delta x. Now let's solve the part A of the question. Here the distance between 2 points that differ in phase S dash. That is, we need to find out delta x. To find out at a fixed time, that is delta t is equal to 0. It is given that the change in phase is equal to S dash, and in radians we can write delta phi will be equal to pi by 180 into S dash. Therefore, delta phi is equal to 11 pi divided by 3.6. And we know that delta phi is equal to omega delta t minus k into delta x, where since it is at a fixed time, delta t is equal to 0. Hence, delta phi is equal to minus k delta x. And delta x is equal to 1 by k delta phi, where k is a wave number, where k is equal to 2 pi by lambda. Let's substitute this. Therefore, delta x becomes lambda by 2 pi into delta phi. Now, the wavelength is given by v is equal to lambda by t. Hence, lambda will be equal to v into t. And v by f is equal to lambda, since f is equal to 1 by t. Therefore, we can find out lambda is equal to 353 divided by 493, which is equal to 0.716 meter. Hence, delta x will be equal to 0.716 divided by 2 pi into 11 pi by 36. Therefore, we'll get the value for delta x as 0.1094 meter, or delta x is equal to 10.94 centimeter. Now let's move to the part B of the question, where the phase difference between two displacements at same point but at times differ by 1.12 milliseconds. Here, delta t is equal to 1.12 milliseconds, which can be written as 1.12 into 10 raised to minus 3 seconds. We know that delta phi will be equal to omega into delta t minus k delta x. So at some fixed points, that is at delta x is equal to 0, delta phi will be equal to omega into delta t. Therefore, omega is the angular frequency, that the equation will be omega is equal to 2 pi f. Let's substitute this into this equation. Therefore, delta phi becomes 2 pi into f into delta t. Now, let's substitute the values. 2 pi into 493 into 1.12 into 10 raised to minus 3. Hence, we'll get delta phi as 1.104 pi radians. Now, in degree, we can find it out by delta phi will be equal to 1.104 into 180 degree. Finally, delta phi is equal to 198.77 degree. Hope you find this video useful. Thank you.